Okay, let's see. Share the stream. Hello. Let's just wait for this. Okay. Let's see. PyCharm. Good. Faster. Is it okay? Bismillah. Kadang ni pun tak percaya. Tak apa. Kita pakai ni je. Okay. Mana? Kejap. Kenapa? Oh, okay. View all. Kejap. There you go. Wacom. Mapping. Port landscape. Monitor 2. Full. Okay. Okay, that's good. Okay, welcome everyone. Assalamualaikum. So we begin our our class with Kita Al-Fatihah. So I'll be sharing my screen here as well as on YouTube. So everyone who cannot attend, everyone who just happens to watch this stream also can ask in the chat, okay? Whether it be Gmeet or Google what do you call it? YouTube chat, okay? So now today we are going to learn about linked lists, okay? So basically before this we all learn about array. Array is basically the basic thing that basic data type that we learn during C++ or C or even during our basic programming class. Okay, so what we learn is that an array is just some data that is arranged in a particular order. Okay, give me a moment. Admit all. Okay, so this is an array, and we have linked list. Linked list is a bit different than array, where an array we can easily access or any elements at once. Where in other words, if you want to check the third element, the third element in an array, we can easily access it. However, linked list is a bit different. Linked list, you need to have a header to tell you that, oh, this is the head of the start of the linked list. So when you want to find the third element in the linked list, you need to begin with the header, and then you go to the next element, and the next element until you reach the third element. Okay, so that is what linked list, that is what array does better than linked list. However, array has a caveat where an array has fixed size. It is not dynamic, it is static size. So if you want to make a if you want to create if you want to resize your array, you cannot. You need to set it at the maximum, which is a waste of space. However, linked list, you can dynamically resize your list according to the size of your data. Let's say if you want to make you want to create 10 data, and after that you want to create 15, you can just add another 5 element at the end of the at anywhere, not at the end, not only at the end, but anywhere in the linked list. Okay, so far everyone understand about that?
Yes.
Okay, good.
Yes.
Okay, so what are the elements of a linked list? Okay, so let us begin with one thing. We begin with the node. In the linked list, we call this as a node. This node can also be used in other data structure, like trees and graphs. Okay, but for now we use nodes in linked list. Usually a node has two things: the data that it holds and the link. The data, let's say this is node 1. The data part holds the data, is where the node holds the data, whether it be integer, float, double, string, or characters. Whereas the links refers to a pointer. Basically, the node holds the address of another node. So this link is what links this node, the first node here, to another node, the second one, like that. Okay, so this link, or in better terms, pointer, is what points to another node. Basically, from this node we can go to another node. This is what makes it very powerful in terms of resizing, because you can attach and detach any nodes from other nodes, like that. Okay, now we've learned about the nodes, so that has the data and the link. Sometimes in certain nodes, there can be multiple data, and there can also be multiple links. But for now, we only focus on one link and one data. Okay, the most important part is the one link lah. Now we go for the linked list itself. The linked list, as I mentioned, you need to have a starter, the one that begins the list, that tells you, okay, this is the beginning of the list. So imagine, so the first one, this is the header. This header points to a node 1. So meaning that when we want to access the linked list, we go to the header. Oh, the header said, okay, the first node in this linked list is node 1. So you go to the node 1, and node 1 has the data as well as the link to another node. This link variable, this link data can also be this pointer can be empty, meaning that we have reached the end of the linked list. Okay, so for easy purpose, we only focus on the header, the nodes, which is the elements, and then let's say this is node 2, which is another data, and then we link again with another node, node 3, and another data. And if there is no node after node 3, which means we have reached the end of our node. Okay, and our not node and our of our not data, what do you call it, the end of our linked list. Okay, so now let us try to implement the basics first. We begin with the node itself. Okay, if you guys have read the chapter 1 linked list.py, you may know which part I will talk about. We will talk about the node itself. So let me just zoom in. Where is that zoom button? Alt Shift. I'll make it 30. Okay. Can you see the code?
Yes.
Okay. Since we are only focused on 1 hour, so I'm not going to start from scratch. So I'm just going to explain one by one. Okay. So first we begin by initialize the class. Okay, I haven't introduced you to class. Okay, a class is basically a bunch of functions that is defined under an object. Okay, basically a class is basically a template. We can say class is a template to create an object. Okay, so from here we have the class node. Okay, meaning that, okay, this is the template that has functionalities to create a node. Okay, so first let's see, in this class, in this template, I'll sometimes use template, I'll sometimes use class, but just understand that I'm just referring to class. Okay, so in this template, the first one is the define, which is the function function declaration. Okay, initialize this is fixed. Okay, underscore init underscore. This is the constructor. Okay, the constructor function, which means when we want to create the object name, when we want to create an object using the template node, we want to tell that object what you should do first. Okay, so from here, let's see, we have define, initialize. So this is the initialize, and then we have the self. Self means we want to refer to the node itself. Comma, data equals none, link equals none. This is the parameter, and we also have known that the equals none mean this is the default parameter. If we don't give anything, which means they can use the default one, which is none. And then we want to initialize, self data equals data, which is the parameter that we pass to, and self.link is link, which is also the parameter that we pass. So basically, when we want to send the data, we want to say, okay, I want you to create node class where the data of that node is what, and the link of the node is that goes to where, like that. Okay, so this is the constructor, the one that initialize the node. And then we go for the other one. This is optional, just to make it easier for you to understand what is going on with the coding. Okay, so basically, If you want to update data, this is how you can do it like this. You want to set link, you can do it like this. If you want to remove link, you can remove the link by set the link equals to none again. If you want to get the data, you can return the data using this function. And the get next basically means you want to get the next function, a next node. Okay, so this is basically some basic user-defined operations of node. If you don't want to do this, it's okay, but you might not understand your code later on. Okay, so I would recommend just do the function even though it is basic, just so that you understand, oh, this function is to update data, this function is to set link, this one function is to get data. This is basically another good thing about functions. You can name your operation. Okay, so basically this is everything that we need. This is the most important part where you want to initialize the data and the link. Now we go for the before that. Do you understand so far about my explanation about the node, the linked list, as well as the coding? Are there anything that you want to ask? YouTube, anything? Anything you want to ask?
Tak tahu.
Tak tahu? Tak tahu apa yang tak tahu? What do you don't know? Because I think because we are quite this one hour, so I'm pretty sure most of you might not understand. But it's okay. You can't ask me again personally through WhatsApp, okay? But just don't spam my WhatsApp lah. I might not be able to answer all of your questions. Okay. So since there's no question, I'll just repeat. The class node is basically the template where if you want to initialize an object using the template, you can use the __ init __, and then you can define what parameter you want to give to the class, to the object, and what should they do with the object, with the parameters that you give. So that's basically it. And then this is the necessities of operating the node, and that's basically it, the node itself. Now we go for the linked list itself. Linked list. The linked list, as usual, the linked list, as I mentioned just now, that we are introducing a template or a class, which is LL. You can use other names. You can use class linked list or class list. You can do it like that, no problem. Okay, and then you can define. When you define self, this one I did not give any nodes, so I put define initialize self, where I put the header. In the linked list, the header is set to none. Okay, the header is set to none, meaning that when we first introduce, okay, I want to create a linked list, so we create the header first. So this one does not exist yet. So this is gone. Maybe I can do it like this. So when you first begin, header is gone. We only have the header. Okay. Oh, why do I? No. I don't want to record. Okay. So now we want to add a node. Okay, we want to add from an empty header, we want the header to hold a node. So we add one. Okay. So what do? We put add to start. Define add to okay, I think I need to explain this as well, because you need to consider yeah, just do it. Okay, so now we want to add a node, we need to consider multiple scenarios. Okay, first of all, let us begin with adding the node at the start of the list. meaning that we want to push into the linked list. So what do we do? What do we do? Okay, let's say I create a new one. This is a header. I put H here, and I want to I have my first node. So this is node 1. Let's say the header has no list, the list is empty, meaning that the header does not point to anywhere. So what can I do? I can set the link of the header to the first node. Okay, this is add to start function, or we can call it as push. I'll go in depth about the push later on in the next class, but for now, let us focus on add to start. Okay. Okay. Now we want to create another one. So we already we already add a node to the start. Now we want to add another node to the start as well. So what are we going to do? First, what we should do is we need to set, we need to first set the link of the node that we just created to the header of the node, the header of the link, basically the first node in the linked list. This is the first step. And then the second step, what we should do is we change the header link, which is the self.head, so that it points towards the new node that we just created. So this is the second one, and this is removed because we change like that. Okay, so let us try. Let us take a look at the node. So what we do, define add to start self comma data. Okay, so temp node equals node data. So basically we create a temporary node where the node where we want the node to save our data. So this one. Okay, after we save the data in the new node, we want to set the link of the node to the self head. This is the first one. This is create the node. This is the first step. First step that I mentioned. And then since we already linked the temporary node to the header, we want to link the header to the new node. Okay, this is the second step. This is the second step. We change the pointer so that it points towards the new node. Let's change this to new node. Okay, so for others, let me just skip this for now because I want to demonstrate. Let's just like this. List dot add to start 10, and then I'll just put the display. We have display. Okay, and then we do again list dot add to start 20. I'll explain about the display list later. Okay, add to start 10, and then we put another one, list dot display list. Let us try running this. Current file, we run this, and we get 10. This is the starting of the list, and then we push another one. We add to start, so 20 is pushed to the front. So now 20 is in front, followed by 10. If we do the same, let's say you want to do it again, list dot add to start let's say 25, and I want to display it again. I will get 25, 20, and 10, like that. So far, do you understand about this?
Yes.
Okay, good. So basically, when we add to start, we want to put it in front. Okay, now since I already mentioned about the display list, we'll go to the display list and then we go to the we continue with add to end. Okay, now we want to go for display list because this is going to be important for the next for the other related data other related functions. Add to start, add to end. Okay, where's the display list? Okay, this one. When we want to display list, this is what happened. We go back to here. Basically what we want the function to do is you want the function to go through every node and display what data do they hold. Okay, so let us begin with the first data, first one. Let us take color purple. Is this purple? Let me take a look. I'm using nightlight, so I can't be sure. Okay, good. Let us change color lah. I'll take color green color. So what happened when we want to display the list? We have to make sure that it begins from the header and it ends at the end. And since you only know when we create the list, we only know the header, and the header holds the rest of the list. So we go to the header. We go to the header. We ask the header, what is the first node of the list? If the header has a node, then it will bring us to the first node. When we go to the first node, then we can do whatever we want to do with the first node. We want to display it. We want to do some addition or subtraction. We want to do some checking. And then after we finish with the first node, we check the link. Is there the second node or the hey, node number 1, do you have the next node after you? And the node number 1 said, yes, I have. So now we go for the second node. And we do the same thing. We do the same thing for the second node. This is basically a while loop or a for loop. And we check again. We check again. Hey, node 2, do you have another node after you? And the node 2, said, yes, I have. So if the node 2 said yes, so we go to the third node. And then we do anything we want to do with the third node. Basically the same thing with what we have done with the first and the second node. And we check when we ask the third node, hey, third node, node number 3, do you have another node after you? No. Then if we have reached if we have no node after, if node 3 said there are no nodes after me, then basically we have reached the end of our function, our linked list. So in this case, I'm talking about display list. So what am I supposed to do? We go for the header, we go to the node 1, we ask for the data from node 1 and we print out. And then we ask again, do you have another link, another node? The node another node after you? The node said yes. We go to the another node. And we do the same thing, until we reach the end of our linked list. That's basically the premise. Okay. So this is how you implement the node. Implement what I'm saying just now. So first of all, we put, okay, I want to say the current, let us set the current is the self-head. Meaning that, imagine we are in a car, we go to the header node. We ask the header node, do you have the first node? They said if the node is empty, we said, oh, the node is empty. So we go back. Else we check while there's while there is still a node, this is what does it means. While current, which means while the current node exists, okay, since for now we have the self-head, so self-head is the current node now. So what do? We get the data. And we print out. So we print out current.getData. So we ask for the node. Oh, sorry, not this one. We ask for the we go for the first node, we ask for the data, and we print out the data. This is basically it. One line. And then we go to the next node. Current equals current.next. So what do we say? Okay, node 1, give me your next node. So node 1 will give the next node. So we go to the next node. And we check if the node exists. This is basically another thing lah. This is basically on your creativity. So we already go to the next node. So our next node is now our current node. Excuse me. So if it exists, so we print out the arrow, which means we are going to the next node. Okay. And then we go back. We check if the current exit with the next node exists. We do the same thing. And we repeat until we have no more nodes to check. Meaning that we have reached the end of our list. So when we have reached the end of our list, we go out and we finish our display list. So this one is just optional. We can print out because we want to make a new line. Oh, I forgot one thing. Notice we have the n equals space here. What does it mean? Because previously we don't have the comma n equals to space. But now in this chapter we have this. What do they differ? My first question. What is different? If we have the n parameter and we don't have the n parameter, what happened? Can someone tell me? What is the difference if we don't put any n? Don't give any specific parameter for the n, and we give space. What is different? Try to do it. Yourself. This one I already checked. So for simplicity, I'll do this. Print ABC. Print BCD, comma, and equals space. And then another one, I'll just do another one. Print XYZ. What will happen if I run this? Anyone got answer? No answer. I think everyone just everyone just prepare for sorry. It's okay. So basically, when I run this, what will happen is the first ABC, when there's no n parameter, it defaults to new line. So when we print ABC, it ends with a new line. So it goes to a new line. However, if we put the space or anything here, basically we want to tell the programming, we want to tell the program, okay, I want you to end with a space. I don't want you to end with new line, like that. Let's say if I want to say 10 here. So it will end with 10, like that. Okay. So do you understand?
Yes.
Okay, good.
Yes.
Okay, so back to the linked list. About the linked list, do you understand about how do we do the display function? Display list function? The visuals as well as the coding itself. Hello? Anyone?
Trying to process.
Okay. I'll give you 1 or 2 minutes to process everything. Because later we want to do the add to end. I'm not sure if we can cover all of the functions, but maybe I can make you do some of them so that using the basics that we have. Okay. So are you ready to get to learn another one? Another several functions?
Yes.
Okay, good. So let us go for add to end. We have learned about add to start. We have learned about display list where we pass to all the lists. Now we want to go to the end. How we want to do to go to the end? So basically, the concept is similar to display list. However, the difference is when we end the program, when we reach the end. Okay? Same thing. Basically the same thing. So I'll just duplicate this. I remove this and I do this. So this is the new node. So we want to pass starting from the header, we go to the next node. We don't want to do anything, we just want to go to the end. So we ask node 1, do you have another node after you? The node 1 said yes, we go to the next one. And we ask this node number 2, do you have another node after you? The node 2 said yes. And we go to the third node. The third node, we ask the third node, do you have another node after you? And the node 3 said, no, I don't have any node after me. I think you have reached the end. So when we have reached the end, now we can do our operation. So what do? We take a look at the link just now. We take a look at the link. We attach it with the new node. Like that. Okay, which is different than the first one where we change the link. This one, we put the link to the new node at the end. Meaning that we add another node at the end of our list. Okay, this is different than the array. Array, cannot do it like that. We can just simply just put it immediately. However, we don't know what is the size of the usable array. Whereas in linked list, we go one by one, and when we reach the end, we put the new node there. That's basically the premise. Okay, so how do you do that? The same thing. So current equals to self-head. A new thing. If the current is none, meaning that if the self-head is empty, we don't have the list. So what I put here is that, this is basically just add to start. Because basically we just add one node. When we add just one node to an empty list, it's basically the same thing for the add to start and add to end. So what I do, I just call the add to start function. Like that. However, if the header is not empty, now we consider going through everything. So we go delete temp node equals to node data, and then we check if the next node exists, we go to the next node. If the next node does not exist, okay, good. The next node, we want to set the link to the temporary node. So this is This is the step 1. And this is also step 1. This is step 2. Because step 2, we have reached the end of our linked list. Both of these are optional. Okay, both of these are optional. If you want to delete the temp node, you can. If you don't want to delete also can. But I would recommend you to delete the node, probably because you want to free up the space. Okay, because Python uses a lot of RAM, I suppose. Okay, so now we are going to do the add to end. Okay, so let us go back here. Now let me change this. What will happen if I do it like this and I want to display it? What will be the outcome? What is the order of the list? Which one starts first, and what element will go last? Okay, I want any one of you to answer the question. Can you tell me the order of the list?
Brother, the cursor is on the way.
Okay, sorry.
So 20, 10, 25, 35.
20, 10, 25, 35. The others?
Same.
Same. Okay. Sister, did you agree with both of these brother? If no one, can you tell me the answer, your answer? If no one, we proceed. No one? Okay, no one. Okay. So that's so what happened? Okay, let me just run this. And what do we get? We get 20, 10, 25, and 35. Okay? Like that. Okay, so that's basically it for we have the add to start and add to end. Now we are going to go for, if I want to go for each one of these, it will take at least 2 more hours. Okay, we have the max list, which is basically you need to find the maximum number in your list, given that you put only numbers in your list. If you put a string in your list, this max function won't work. Okay, that's why. Okay, so we already learned about add to start. We already learned about add to end. We want to learn the max list and the minimum list. The max function and the minimum function is basically the same thing. Okay, you have to combine what you learn about the linked list as well as what you have learned in the typical for loop or while loop here. So basically what do we do? Same thing, we go through all the lists, and what do? We go, if the current node is greater than the value that we have, we change the value. Else we keep the value that we have, like that. That is the max value. For the minimum value, if the current data is lesser than the data that we have, then we go for the data, then we change the data. Else we keep the data that we have, like that. That's basically the premise for the max and min. Okay, so I won't be asking you that. Length. Length also one thing where instead of you displaying everything, you count one by one how many nodes are there in the list. So we have the current equals self-head. If the current is none, return 0, meaning that the list is empty. Else we put count is 0, and we count every node that we found, we add 1. And when we reach the end, we return the count number, like that. Okay, so that's basically the length. For the clear list, it's basically we set the header to none, and that's all. That's basically it. I think you guys can access my code, right? The code on the GitHub, right?
Yes.
Okay. The push and the pop and Q and DQ, we will talk about it in the next class on the queue and stack. So I won't be touching them for now. Display list we already talked about, max list we already talked about, min list also talk about. Range optimize. Okay, range optimize we have both. Okay, for this one, since we already have the max list and we already have the minimum list, so you can create the range list like that. Okay, where you find the maximum, you find the minimum, and you just minus them. It's easy. However, if you want some challenge like me, I already done with the previous class, you can try to optimize as much as you can, or you try to cram as much as you can into a single function. Although I would not recommend this, because you might not understand what you are doing. Unless you read one by one, then you might know something. But for me, it's not recommended, because if you want to do it in a group, you have to make sure your group also understand what you are doing. Okay. So these two. We also have the total function, where we go to one by one node, and we calculate the total of the data that we have in the node itself. And then we have the calculate average, where we find the average of we find the total, and we divide the length. We use again the function that we have to calculate a new function. Okay, for this one, this is a bit challenging. Sort increase, sort decrease. This one I'm going to skip this because it's too. We want to go for the easier part first. Find data. For the find data, what we can do is the same thing. We go to each of the node and we check if the data that we need does exist in the node. If we found one, we can end the function. Else we can go till the end, and if we don't find anything, or the the data is not found in the list, like this. So current self-head, if the list is empty, we print list is empty. Else we find, okay, K1, and then we check the current node. Okay, if the current node has the data that we have, so the data is found at the list in the list at index K, and we return K. And then we check for the next one, we check for the next one, we return. Else we check for the next node, and we do the same until the end. If we don't find anything, we just print the data is not found in the list. So let us try to do this. Okay, not do this. Let me demonstrate this. So we put max. I think I return print max, I suppose. Is it like this? I don't remember. Okay, good. print max, print min, print length, print total. This is everything that I have mentioned. This is basically more on you guys just relearning everything but in linked list style. Average. And the last one is the range. Okay. So when we run this, so we have this. So the maximum is 35, the minimum is 10. The length is 4, the total number is 90, the average is 22.5, and the range is 25. The maximum and the minimum is 10 is 35, like that. Okay. Now we go for the find data. Find data, so we want to check if the data exists, right? So we find data, list dot find data. Let's say we want to find number 25. And then we also want to find list dot find data 15. Okay. So we have that. So this one I'll just comment this. Later I will delete everything here because this is fixed. Okay. So we have 25, we have 15, we have 10, 20, 25, 35, and display list. Okay. So when I press run, the check, okay, the data 25 is found in the list at index 3, which is true. It is at index 3. How about the 15? 15 is not found like that in the list. So this is the find data. How about get data? The get data is basically we want to look at the third data or the fourth data in the list and we want to extract it. Okay. So basically what do we do? First, we check if the list is empty. We return list is empty. Else, we go from 1 to 1 and then until 1, 2, 3. So we check if while current, if k is equals to index, meaning that if we have reached the node that we desired, so we say the data, we print out the data at index k is the data that we have. And then we return. Else, if we search until the end and we don't find we notice that the position of the node is not within the size of the list. So we say the index desired is not within the size of the list. Okay. So before anything, do you understand everything that I said until now? The maximum, minimum, the length, total, average, range, find data. I have 10 minutes. Yes. Okay. So apparently Jimmy said you have 10 minutes to talk. Okay. So let us make it fast. So get data. 2. And let us clear this list. Dot clear list. And then we put list dot get data. 2 again. What will happen? What will happen with the first get data and what will happen with the second get data?
Can you repeat the question?
Basically, I did not change this. I only want to get the data on the second element, second index in the list. and then I clear the list, and then I want to ask for the same thing from the list. What will happen for the first time I want to get the data, and what will happen for the second time I want to get the data?
The first time there's an element, a value
Okay, it gives a
of the,
value. Okay.
but the second one no more because you cleared the list, right?
Yes. You cannot get the data anymore because you have cleared the list. So when I run this, so it gives list is empty. But the first one, we get the data at index 2 is 10, like that. So we have 9 minutes left. Okay. So since we already know how to get the data at certain index, we can remove the data from the certain index. Okay, for the remove part, this is a bit tricky because I haven't mentioned about the remove part. Okay, you know that we can just clear the list by just removing the link. So when we clear the link, so basically the list does not exist, like that. So when we clear the link between the header and the list itself, basically the list does not exist, even though it still exists somewhere in our memory. But since we have removed the pointer that points towards the list, so basically the list is not reachable again. We need to create a new list. Okay, that's the premise. Let's say if you want to remove the end node, so for example, you want to remove the node, you want to remove the end of the node, like here. So since there are no more node after that, we can just remove this. We can just remove the node here. So it does not exist. So node 2, the link in the node 2, the node 2's link, the link for node 2 does not point to node 3 anymore. It points to nowhere. So node 3 is assumed to be not exist, like that. Okay. So this, you can find that one here. I did not put anything here. Oh, oh yeah, that is under push and pop. Yep, that is under push and pop, actually. Yep. So okay, I will talk about this later on. The pop and the DQ. However, if you want to remove a specific index, it becomes tricky, because basically, let us consider this again, but this time we don't have this. So let's say you want to remove the second node. Okay, so what you do, you take the first node and you bypass the second one. So the second one does not exist when you want to access it, because you already initially it is the link from the node 1 goes to node 2, but you set it to go straight away to node 3. So node 2 does not exist, like that. How do you want to implement this? It's very tricky. This is very tricky because you have to consider, what if the node is in the beginning of the list? What if the node is at the end of the list? If the node is at the beginning of the list, you can directly set header. You need to make the header go straight forward to node number 2. Okay, because the header is already there. But if it is in the middle of the list, you need to consider the previous list, the previous node, and the next node, because you want to attach the link of the previous node goes to the next node, skipping the current node. Do you get what I mean?
Yes.
Okay. So in in coding terms, Where is it? This one. So basically, if the node is empty, we put node is empty. Else, we check. If we are in the current node, if the node that we search, if we have reached the node that we want, so we go to we take we need to introduce a new node, which is the previous node. So what do we do? What do we do? Peningnya aku. Just give me a moment. Okay, we have 4 minutes left. Okay. So let's say if it is in the beginning, so we don't have any previous node, we only have the header. So what do we do? If previous is none, meaning that we only have the header, we don't have the previous node. So we put the self header goes to the next node immediately. And else, if the previous node exists, we want to set the previous node, the link of the previous node to be the next node. Meaning that the current node that we are in is skipped. Okay? And then we return. Else, we continue. And let's say, if we reach the end, that means we will say the index desired is not within the size of the list. Like that. You can try this more on your own. I won't be talking longer. However, okay, this one I already mentioned, do the practice in the class, so I won't be giving you the same challenge again. This is also already done, I suppose. This is also the challenge one is not done yet, but the implement several function is already done. The remove by index. This is what I have taught you just now. Okay, so since we only have two minutes left, okay. So what you should do is I'm going first. It's on you if you want to use the list that I have given, the coding that I have given, or if you want to make your own list. If you create your own, I will give a bonus lah. Okay. If you create your own, I will give you a bonus. But if you want to use mine, also can. I think no need lah give a bonus. You can use mine as well, no problem. Okay, it already have 1 minute. Okay, the first one. I want you to implement several functions. Okay, the first function is to count how many even numbers. The another function is to count how many odd numbers in the list. Okay, I will test them. Okay, I think we end our class with us. Yeah. Okay. This. Okay. So, let's see. Let me go to the Google Meet. Okay. Okay, so I hope everyone is here. Where is everybody? Okay, so since the Gmeet class has finished, early. So I'm going to talk to you through the YouTube chat. Okay, to the YouTube stream. Okay. Basically, I want you to do several things. Okay, I'll update as well in the Excel. Let me just uh, let me just go for this. Okay, you can see this live. Okay, so what I want you to do for the practice. Okay, let me just, how do I zoom this? How do I zoom this? Okay, there you go. Okay, so this is 2 marks. This is also 2 marks. Two marks. Okay, so for the practice, for task 2, okay, where was I? Okay, so 2A. Okay, for task 2, you may create your own linked list function. A linked list coding, or use mine instead. Okay, so for the first one, create a function that counts the even numbers okay, two functions odd, let me see, odd, count odd, and count even, that counts even numbers. Even and odd numbers in the list. Three marks. Okay, so basically if you can do even and odd, both of them are correct, you get full mark. If you only get one of them correct, you only -1. If your coding does not work, one only. If you don't give anything, you get 0. That's all. Okay. If you don't give any effort on trying to do your coding, you get 0. If you try to give an effort, you get 1. Okay. 2B, for 2B, create a function that swaps, this is challenging, swaps 2 elements in the list using their index number. This one is challenging, okay? So, but it's There are no other. I'm not sure if. Although it is challenging, it's still worth 2 marks based on ni. Okay, 2 marks. And then so we'll have. We already have 11. The third one. 2C. Let's see. Apa lagi nak tambah? I think this one I give 3 also as well lah. Because I think this is hard. For the third one, let's see what question do we have. Insert the data into a sorted list while keeping it sorted. Okay, this one is challenging. I won't be grading you this. If you see this, I won't be included. But if you want to try it, sure, no problem. Let me see what else can I do. Okay, last one. Create a function for this one. This is a new one. I think you can do it. Macam tu je lah. I think it's okay to be like this. I don't want to give you some more ni. So create 2 functions, count odd and count even, that counts the even and odd numbers in the list. The second one is create a function that swaps 2 elements in the list using their index number. Okay, both of these are 3 marks. Okay, and this is the current marking that I found from the ni. Okay, the reason why there are some of the groups that have 1 mark, 1 point, while the others have 2 points, and some also we can see we have 0 point here. So basically, what does this means is that if it is 0, I did not see your code. There are no codes relating to that task that I can see in your repository. If you get 1 mark, it only means that your coding works. However, there are some hiccups. And since this is 2 marks, so because of that hiccup, I have to give you 1 because you did not fulfill the whole requirement. Okay, I will check again. I will check again for these 3 groups: group handsome, group use humor to cope, because you did not give me any name, so I use the name of your repository, and Ifanda Wish, because you also did not give me your name. So Ifanda Wish, please take a look at what you did not fulfill. For example, I'll give you an example. One of the groups mentioned about showing the numbers from 0 to 50. They show them all. They also mention which number is even, which number is odd, except for certain number. Okay, that's one. Another group, what they did is that they did not consider that the user needs to that the user can input as many number as they want. This is for the total and average problem. You should give the total and the average of the you should provide the program how many numbers that the user want to provide, and then calculate what is the total, what is the ni. Some there is a group that just calculates two numbers and then that's all. Whereas I want the user to able to give as any number that they want. That's another one. Another thing that I found is that you forgot to consider negative numbers. You forgot to consider negative numbers. There is a team that suddenly use absolute function in their coding, which is unnecessary. So please remove that, because you need to consider negative numbers as well. And for the GCD and LCM, there is an edge case where there is an input that I put where one of the number is a multiple of another number. When I try it, one of the group failed to calculate the outcome, calculate the value. So I have to give you 1 for that. Okay. That's all. Are there any questions in the chat before we end our class? No. Okay. So that's all. Okay. For the second task, I will tell you what I will use to test your code. Okay. I will tell you what test I will use in your code. This is task 2A, task 2B. The full mark is 3. Okay. So basically, I think I will add it in the, where is my GitHub? As I mentioned in the grouping, you may create your own linked list coding or use mine instead. Okay, you can create your own, or if you want, if you're, I don't know why, but if you are too lazy, you can just use mine. Okay, I hope that answers your question. Let me see. Where is this? Is it this one? Okay. So let me just copy and paste. Let me, is there a way to zoom in? Okay, good. Input 1, 3, 3, 4, 5. Input 2, 5, 1, 2, 3, 4, 5. This one, no input. This one, input, the input is 100. This is the input one, but I can put either way. I can put 105 or 5 and 100. It's on me. Input 2, 3, 2003. Input 3, 81 and 15. This is the input, okay, for the task one that I use. And I just put problems one txt. Can I duplicate this? Is there a way to duplicate this? Oh Lord. Edit this file. No, I don't want to edit this file. I want to save it as another file. Oh Lord. Give me a moment. Why do we go from here? Problems for class. Create new file. Not go to file. You know what? I'll just make a new one. Copy. Make a new text. Notepad. So task 2. Let me just change this. Copy. No input is required, okay? However, I will do something with the code beforehand. I will. Mana dia? This basically means that everything below here will be cleared, okay? Because this is the part where I want to test out your coding, your functions, okay? Mm-hmm. 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 There you go. Okay. Nanti abang turun makan. Nak terawih. Okay, awak ambil. Okay. Oh, almost finish. Okay. So, okay. Boleh. Okay, I think itu sahaja. Okay, nanti kita nanti pula I forgot that I'm in class Python. Okay, so I think that's all. So we end our class with tasbih kafarah and surat al-as. So I masih selamat menyambut bulan Ramadan. Happy fasting month, and hopefully inshallah our this year our Ramadan is better than the previous year. So we end our class with tasbih kafarah and surat al-as. Okay, so that's all. I'll see you in the next class inshallah. Assalamualaikum. Let me just end my class. You're welcome.